Hey guys, it's Vince. Today in this video, we're going to be looking at what's supposed to be a better way to calibrate your steps unit on your CNC. So I'm going to let this guy speak for a little bit. I want you to hear where he's going.
They tell you to move an inch and measure and see how far you went. And there's a calculator built into Mach 4 that will automatically do the math for you. And so they tell you to do that back and forth a few times over the inch, and then to verify it by moving the machine 5 or 6 inches or something like that. Well, you know, if you're off just 1/1000th of an inch on over the distance of 1 inch, at 6 inches you're off 6/1000ths of an inch.
That's correct.
Or if you're only off 1/2,000th over an inch, that's pretty good, I would think, if you're using cheap calipers. Or
no, 1/2,000th of an inch over an inch on a table that size would be just about as horrible if you're doing precision work. What this gentleman is stating is absolutely correct, in that your accuracy is based on the length of the measuring tool you're using to perform axis calibration on. Let's quantify it, okay? We're looking at this nice chassis he has here. Definitely robust, definitely more industrial type. If he's doing large projects to the full extent of that table, he wants this machine to be as accurate as possible, mainly for his clients and also for himself. If he's drilling holes, if he's chamfering, we don't know what he's doing with this chassis, but we do know that I don't know any client that would own something as robust as that for it to be a good enough guy. You don't want to be a good enough guy. Good enough guys fail. They fail repeatedly, especially with machining, because details are everything in machining. And where he's going with this is basically he thinks he's figured out a better way to take measurements from. Now, I want you guys to see this, and we'll get your opinion. I'm just going to fast forward this a little bit. He's already covered all those details, and we're going to come up here and we will show you what he's come up with. Check this out.
And you'll see how accurate it can be, and hopefully this is of use to somebody.
Alright, so what I've done, as you can see, I've set that V-bit right on 2 inches, as close as I can get it in. So we're going to...
Now let's go over what is wrong with this, which many of you already shaking your head. First and foremost, tape measures in general are not precise. And unfortunately, the truth sometimes hurts. 99.9% of the general public, when it comes to reading tape measures, get different measurements every person you give it to. Every job I've ever worked where a tape measure was involved, you'll get different measurements based on who's using the tape measure. Fact. Secondly, we look right here on the screen, we notice that the tape measure is all kinds of bent, warped, because it has use, on top of the fact that there's a nice curvature in tape measures, okay? So that means that your measurements are never going to be accurate. On top of the fact that if that tape measure is not laid out perfectly perpendicular and parallel to the axis when it's jogging, you're going to have a deviation, okay? Now, some guys say, well, Vin, you're being very scientific. You're being too anal about this. Am I? Do you own a robot? Are you trying to do production with that robot? If we wanted to do things by eye, why buy a robot? Watch what happens. Let's see where this goes.
Take away all of the measuring error, whatever measuring error we might have, and it's going to be divided along the full length of the bed. So if my eye is off a couple of thousandths, divide a couple of thousand over, over 8 feet. So this is a real accurate and fast way to do it. So I've set the work.
There is no such thing as fast and accurate. I think we can all agree in machining that's usually not the case. Everything takes time to get to that accuracy. If you are going fast to get to accurate, most of the time those two words don't usually work in the same sentence with machining. So what we're seeing right here is a gentleman who wants to streamline the process of, instead of taking incremental measurements with a precision measuring instrument only calibrated to an inch, he's obviously unaware there's a more appropriate, better way to do this. Okay, so what you see on screen here is a straight edge from Starrett. Now these are precision straight edges. These are not the typical straight edges you buy at Michael's or Hobby Lobby. These are not cheap. Of course, you can go online and find them at a better price, but I want to show you something, guys. Look at the accuracy, looking at 2/10,000ths of an inch positive and negative accuracy per foot. So we only have a deviation of 2/10,000ths, right? Now, most tables are always going to be in feet. He has 8 feet. So if we look at this respectively, if he used this to start the measurement from with a precision dial indicator, which of course he should be using, everybody should be using, that would take that minute indiscrepancy out. If he did that, let's look at the quantity in terms of math. On a 5-foot measurement, 5 foot with an accuracy shown on that straight edge of 2/10,000ths of an inch, he'd only be off 1,000th of an inch over 5 feet. That's way more doable. And that's more acceptable for most applications. When we look at that and you quantify what I just showed you, that would alleviate any use of a tape measure. And once again, it's all about using a precision measuring
instrument. And now I'm going to use the
instrument.
computer and command it to move all the way down to the other end of the table, and we'll see how far it goes.
Let's see.
So here at the table, or at the computer, at the MDI, it's just a real simple command, G0X90. So you can see I've already calibrated this, but there we are, we're right at 92 inches.
He's calibrated it. Now, think about what he just said. He's already calibrated it. He's calibrated it to a tape measure. Guys, think about what I just showed you. You guys be the judge. Be careful with who you learn from. And once again, take your time, do it right.